now we study the property of lower and upper sums. Okay, so let small n and capital M be the lower bound and upper bound of f. Then given a partition P and suppose J is a subrectangle determined by the partition P, we have this inequality. Okay, this is quite easy because MGF here is the infiniment of f over the subrectangle J, and because the subrectangle J is a subset of I, the infiniment of f over J will not less than the infiniment of f over I, which will not greater than the lower bound of f over I. Therefore, we have this inequality. And similarly, we have this inequality. Because J is a subset of I, therefore the supplement of f over J, that is capital MJ, will not greater than the supplement of f over I, which will not greater than the capital M. So we have this inequality. Now, multiplying every term in this inequality by the volume of J and sum up, we obtain this term, small mj multiplying the volume of J and sum up, give us the lower bound of f, which is back to the partition P. Well, small m multiplying the volume of J and sum up, because all the sum of all the subrectangle is the whole rectangle, is the volume of the sum of the volume of all the subrectangle J is equal to the volume of I. So we see that the left hand side is M multiplying by volume of I. Okay, so this proves the first inequality. Similarly, we have the other side of the inequality about the upper sum. Okay, so we get this inequality, and now we consider two partitions P and P prime of the same rectangle I. Two partitions of I. So here is a partition of I. Now here we have a partition of the rectangle I. Then we add some point on the edge and obtain that is we add this blue lines to obtain another partition of I. So two partition P prime of I. Okay. The black line determine a partition of line I, and the blue lines determine another partition of I. Okay. This is two partition of the same rectangle. So if P is a subset of P prime, okay, P is a subset of P prime. So in this picture, our P prime is not the blue line. Actually, our P prime is all the lines, blue and black. P is the rectangle. P is the partition showing in this picture. Blue, black lines. Okay, and P prime is in adds more points in the edges. That is the black and the blue lines. The partition determined shown by the blue and the black lines. Okay, so our P is for our partition P, there are 20 points in this picture, and for our partition P prime is every lines here. Therefore, how many points are P prime contain? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 7. So for our P prime, we have altogether 49 points. So our P is the intersection of the black lines, black segments, and our P prime is the intersection of all the lines, all the segments, blue and black. So the P is a subset of P prime. P is a subset of P prime means that the subrectangle which respect to the partition P prime is contained in some rectangle of the P. Okay. For example, the lower left corner, this rectangle, this rectangle is a subrectangle of P prime, which is contained in this rectangle. That is this one. Okay. So this is the relation of these two rectangles. So in this case, we say that P prime is a refinement of P. Okay. If all the points of P are contained in P prime, so P prime is finite. If you divided the rectangle I into more small rectangle, subrectangle, and all the rectangle are contained in the subrectangle of the partition P. Okay, so P prime is the refinement. So we observe the following properties. Suppose J prime is a subrectangle of the refinement of P, that is P prime. Then this J prime contains in a unique subrectangle of P, say J. There is a unique J from the partition P, such that the J prime is contained in J, and such J is unique. For example, in this picture, the lower left rectangle, one side is blue, the other three sides not blue. This rectangle is a subrectangle of P prime, which is contained in this rectangle. Contained in this rectangle, which is a rectangle of P. Okay. So this is the first proposition. The second, given any J from P, we can take the subrectangle from P prime containing in J. Okay. The P prime denoted by P prime J. P prime J is all the rectangle of P prime containing in J. So such rectangle P is a partition of J. Is a partition of J. Go back to our picture. So for example, we consider the this is the partition P. The left lower corner, this rectangle. This rectangle is divided by these two rectangles from P prime. Okay. Therefore, for this rectangle in the partition P in the left lower corner, the corresponding P prime J, that is rectangles, subrectangles from P prime containing in J, that is these two rectangles. So they are this is the corresponding P prime J. Another example is this rectangle. This rectangle here. Okay, this rectangle is a rectangle, subrectangle of the partition P, and in our P prime this partition, this rectangle is divided into, in this picture, 4 rectangles. 1, 2, 3, 4. So this 4 rectangle is the corresponding P prime J for this J from P. Okay. So this is the very intuitive observation. Now, we also can study the lower sum of f with respect to P prime. It turns out that this lower sum is the lower sum of f over the P prime J. For every J from the partition P, compute the function, compute the lower sum of f over the partition. As we said before, P prime J is a partition of J. Therefore, we can compute the lower sum of f with respect to this partition. That is, we consider the f as a function defined on the subrectangle J. Okay, our f is a function. Our f is a function on the whole rectangle I, but for a subrectangle J from the partition P, we can restrict f in this subrectangle J, and then we because P prime J is a partition of this rectangle J, so we can compute the lower sum of f considered as a function over J, which is respect to the partition P prime J of the rectangle J. So for every J in the partition P, we take we will compute the above lower sum and then sum up. The result is the lower sum of f over the refinement partition P prime. Okay. Similarly, for upper sum, we have the same result. Okay. The proof of this is not difficult. So by definition, the lower sum of f with respect to the P prime J is the infiniment of every subrectangle from the partition P prime J multiplied by the volume of J prime of the rectangle and then sum up. Okay, so and our P prime is the union of the P prime J for every J from the original partition P. Okay, let's have a look. So in this picture, this every rectangle subrectangle is a subrectangle of P prime, and so P prime is this four rectangle surrounded by the dash segments. So this four rectangle from P prime, they consist of the P prime J for this J. J is this rectangle of P. Okay, so for every J, you take the corresponding P prime J and take the union. So for every J here, you take the union. Take the P prime J and then take the union of all the P prime J is precisely every small rectangle that is subrectangle of P prime. Okay, so this is this result. P prime is a union of the P prime J for every J in taking from the original partition P. So this since this is true, and our lower sum of f with respect to the P prime is every such term mj prime v j prime sum over every j prime over the partition P prime. But the P prime is the union of this, so we can all the term can be grouped. For every J in P, you group the J prime in P prime J, sum up and then sum with respect to J. So we have this result. Okay. Now the inner sum here is precisely the lower sum of f with respect to the partition of J, that is P prime J. So this proves our first equality. For the upper sum, the argument is similar. Okay, so this is important. Now using this result, we can have this lemma. Suppose P prime is a refinement of P, that is P is a subset of P prime. Then the lower sum of f with respect to P will not greater than the lower sum of f with respect to P prime. Similarly, for upper sum, we also have the similar result. In other words, the finer the partition is, the larger the lower sum, and the smaller the upper sum. Okay, you define a partition. Defining a partition that is from P to P prime will increase the lower sum but decrease the upper sum. Okay.